Hello everyone, I hope your Thanksgiving breaks have been good. Today we're going to be looking at our next lecture, Advanced Object-Oriented Programming. Within this we're mainly looking at two topics. We have inheritance and polymorphism. And so the reason this is Advanced Object-Oriented Programming is that it's a good idea to have a strong concept of what a class and an object is before you start learning about inheritance, because it's going to intertwine multiple classes at once. I guess the first topic that we can talk about is polymorphism. And so the general idea of polymorphism is that if you have multiple classes, you can have the same function with the same name. And maybe they do different things, but you can have multiple classes with functions with the same name. And then you can call upon them in a similar manner. So let's go ahead and kind of code up an example. So let's say we had two classes, a class dog and a class cat, and they both had a function within it called speak. Then with polymorphism, we can kind of call this speak method the same way for both dog and cat. So let's go ahead and kind of code that up. We're going to have a class dog, and we're going to have a class cat. And so for each one of them, we're going to define a function called speak. We're going to pass itself, and we're just going to print something out, say bark for the dog. And we're going to do the same here. We'll just copy and paste for the cat. And we'll say meow. So let's just make sure that compiles. That looks good. And so the idea here is that if we instantiate these classes, we can call these functions speak in the same manner. So if we had new dog equals dog, and new cat equals cat, and then we had new dog.speak, and new cat.speak, we get bark meow. This is exactly what we want to see. So the idea here is that we're calling the speak method the exact same way, even though they're set up differently. They both have different information in them. Right now it's just simple bark and meow, but we are able to call speak and have that respective function play out in either class. And so one of the ways this is powerful with polymorphism is, let's say we had a list. And with list, we can just add as many objects to it. So we had new list.append, we want to append the dog. And then new list.append, we can append the cat. And then we can say something like, for object in new list, object.speak. And so we get the bark meow in a very similar manner, but we're able to just kind of iterate through the objects in the list and force them to speak. So this is the general idea of polymorphism. And as you're going to see in the next example, this type of coding lends itself very well to inheritance. Alright, so speaking of inheritance, we should kind of go to the drawing board here and kind of draw it out to make more sense of it. So we saw that with polymorphism, we can have different classes with the same named function and then call it in a similar way. So how does this lend itself to inheritance? Well, what inheritance allows us to do is group similar objects together and then kind of create a template for those objects. So we had, in our previous example, we had a dog and a cat, and let's just go ahead and throw a horse in there. So all three of these, we're going to have the speak class for. And maybe we can have some different information in there, like favorite foods, number of legs, color, whatever you really need for that class. But what you can do is you can say, hey, I have all these objects and they're kind of similar to each other. So why don't I create a class which they draw information from to organize my information better? And so the idea of inheritance is to say, hey, I do have objects that are similar to another, and I'm going to create functions inside of it or attributes inside of it that are going to be the same. So why not create almost like a template? And that's what we can do exactly. We can have an animal class in which dog, cat, and horse all inherit from. And so animal class will just be a template that kind of guides us in the right direction. It isn't concrete. You don't have to follow the template 100%, but you get a general idea of where your class is going to go and kind of the structure of the class by inheriting it from a template. And you organize the information better. So the idea here would be we would have a class that we create which acts as a template. And then we can create subclasses which inherit from that template. So like we said, maybe we have speak in there. Maybe we have favorite food. Maybe we have color. And we're going to code this out, and we'll kind of see where it takes us. But the general idea is that we're going to create a template such that we can inherit from it. Hence the name inheritance. So let's kind of go to the IDE and kind of flesh this out in code. And I think it'll make more sense. All right, so let's go back to the code here and let's flesh out that animal class we were talking about, and then we'll flesh out a dog, a cat, and a horse class. So I'll just clear my screen here. So let's go ahead and start with the animal class. And as always, we're going to create a constructor with the init function. And maybe one of the things we pass in is the name. Every time we instantiate an animal, we're going to give it a name. And then we just say, hey, self.name equals name. And then maybe we have a function here called speak. And speak will just print out, hey, I am, and then give self.name. So this is our template in a way. We have an animal class that takes in a name, and it's going to speak and kind of just say the name. Hey, I am whatever the name is going to be. And so the way we can use this is now we can create our cat class. But this time we can kind of say, hey, I want to inherit from the animal class. So we're going to inherit all the functions and all the attributes from the animal class. So now cat should have the speak method already in it. And we'll be able to access this constructor. I'll show you that in a few minutes. But cat will have speak already predefined, even if it's not written, because we inherited from the animal class. So let's go ahead and fill out cat and kind of show you how this works here. We'd have a constructor, and it's going to work the same way. We will pass in everything. Maybe we pass in also favorite food. I like that one. And so we could say self.favorite food is equal to favorite food. But what are we going to do with the name? Because the animal class initializes the name in its constructor. So how are we going to get the name that we used when instantiating cat over to the animal class? And I do think I'm going to have to draw this out. So let me get back to the drawing board. All right, there we go. And so the idea here is we are currently in cat and we want to get back to animal. So we just inherited from animal, so everything that's an animal is now in cat. But we want to speak back to animal. And we can do this with a new keyword called super. And we're pretty much saying, hey, whatever's above me, I want access to it. And I kind of want to access the constructor or the function that's above me. So let's go back to the code here. So we can actually say hey, super, whatever's above me, I want to access your constructor and I want to give you the name. So I'm going to go to the parent class, or the one I inherited from, which is animal, and I want to initialize name inside the attribute name that it has inside class. So now I have initialized an attribute within the constructor of cat, and I've called the constructor of animal and initialized the name. So let's kind of go ahead and create a new cat here. Let's make sure it compiles and runs. All right, so we're going to create new cat equals cat. And we're going to pass it things like the name. The name is going to be Mimi. And its favorite food is Meow Mix. All right, so we can say, hey, new cat dot speak. So we inherited speak from animal, so we should be able to just speak through cat. Let's check out if it works. All right, hey, I'm Mimi. Okay, cool. And of course, like I said, the template isn't concrete. So just because our animal class doesn't have a function called display favorite food doesn't mean we can't add that in cat. Display favorite food. It just kind of takes self, and we can say, hey, print my fave food is self.fave food. And then we can just say, hey, new cat dot display fave food. Hey, I'm Mimi. My favorite food is Meow Mix. All right, cool. So let's go ahead and kind of inherit from animal with a dog and a horse here. And I'm going to get rid of the favorite food for now. So we have dog, and we have horse. And so you can kind of see where the polymorphism comes into play here. Now we have three classes, all which inherit from animal, and they all have a speak function within them. So just like we did in the first example, it's almost as if we had this speak function within each of these classes. But because we inherited, we kind of saved us all the trouble of writing this 3 times. But imagine it's there. It's there, but it's not there. So in the same manner, we can kind of add an attribute like, we could even say we want to instantiate favorite food, and then we can define, actually we'll just say in speak, my favorite food is self.fave food. And then we can just pass that in instead of having to write that 3 times. All right. So new list. So we're kind of just going to append a few of these different objects at once. We don't really need to keep track of them to make changes, so I can just append directly. We'll just create a dog with the name Davy, and his favorite food is milk bones, and a cat whose name Mimi, and favorite food is Meow Mix. And we're gonna have a horse named Cyberpunk who loves carrots. And then we can kind of go through for object in new list, object.speak. I didn't initialize in the constructor self.favFood equals favFood. Alright. So we got, hey, I'm Davy, my favorite food is milk bones. Hey, I'm Mimi, my favorite food is Meow Mix. Hey, I'm Cyberpunk, my favorite food is carrots. So we were able to create a template for animals. All animals are going to have a name and a favorite food, and they can speak. And then we can organize all of our classes of animals through this template. But let's say we know that cats can't say anything in English. So, hey, I'm Mimi, my favorite food is Meow Mix. It just didn't work out for the cat. Well, we said earlier that templates aren't concrete. You can kind of change them up. And so one of the ways is method overloading. So we can actually create a new speak method. And what we can say is, hey, the cat, when it speaks, it's just going to say meow. And let's see what happens. Are we going to run this speak method, or are we going to run the class that we inherited from speak method? All right, so it took out those two lines and it just replaced it with meow. And so this is called overloading, function overloading. And so let's say the template isn't exactly what you need or what you want. You are allowed to change it within the class, even if you inherited from the template. So that's just a cool thing to show you guys, the method overloading. So I feel like we went over a lot of different topics at once, so I'd like to just kind of bring it back to the slides and wrap it all up before we end this lecture. We covered a few things: polymorphism, inheritance, the super keyword, and function overloading. So polymorphism pretty much said that you can have multiple classes with a function inside those classes with the same name and then call them in similar manners. We had dog and cat that both spoke, and we kind of just called the speak function on either dog and cat, and we got the respective code that was written for that function. That was polymorphism. Then we had inheritance. And inheritance said, hey, we can create a template such that any object that we instantiate or any class that we create can pull from this template. So we can create, for example, a template animal, and then anytime we create a new animal, we can pull from that template. If we make a cat or a dog or a horse or anything along those lines, anything in the same category, can pull from that template that we made, and it makes our code a little bit more organized, and we kind of have a more clear direction of what we're going to do. And this led us to polymorphism because a lot of our classes that we create, if we have cat, dog, horse, they all are going to have the functions inside animal. So we had a speak function, so every class, cat, dog, and horse that inherited from animal are going to have the same function, which are going to be called in the same manner. So inheritance had polymorphism in it. And we saw a new keyword, the super keyword, which pretty much said, hey, I'm going to go back to who I inherited from, the class above me, and I want to access something from that. So I'm going to go to the thing that's super to me and maybe access the constructor and pass it some information that we might need for it to initialize within its class itself. And then the final thing we saw was function overloading, which said, hey, We might have a template we inherited from. For example, we inherited from animal, but then in our cat class, which inherited from animal, we were hesitant to use the speak method that was predefined, and we wanted to write our own. And that's totally acceptable, and we're going to pull from the cat class if we ever call. If we instantiated cat and then call that speak class, we're going to pull from the cat instead of the animal, and we saw that live. And that pretty much summarizes this lecture of advanced object-oriented programming. I hope you learned something. I hope this was a fun lecture. You can use this information for the assignment that's currently out, and I hope this will be enough information to help you finish, help you get started, whichever step you're currently at. And as always, we are available in Discord for any questions. Well, thank you, everyone.